Question 3, part A. We got fx equals to 2x square minus 10x, and right, we got 2x square minus 10x, and they want you to solve the f of modulus x equation. So if you take the given curve which cuts at 0 and 5, when you factorize this, you will see 2x into x minus 5. So this original curve goes through x equals 0 and x equals 5. And f of modulus x curve means you have to reflect the curve for x greater than 0 onto the y-axis. So this curve will probably be like this. So this up to x equals 0, the curve will stay the same, will remain the same, and then get reflected as a mirror image like this. So let me draw it once again. Right, this would be the final curve for y equals f of modulus x. Right, so f of modulus x being equal to 48 means you need to find the intersection points of the line y equals 48. So remember, this point A and this point B, they have the same y coordinates, and the x coordinates should be the same, just with plus or minus. So we just need to find one answer which has x positive, and then you take the negative value of that. So we can use 2x square minus 10x being equal to 48, x square minus 5x minus 24 equals 0, x minus 8, x plus 3 equal to 0. So x equals 8 or x equals minus 3. However, we took this under the condition we are taking x greater than 0 or equal to 0, because we were using f of modulus x and only positive x values exist, and then we take the reflection of that on the y-axis. So this cannot be a solution, which means x equals 8 is our solution. However, this side, point B, also should be a reflection of point A on the y-axis, so that will be minus 8, this will be plus 8. So the solution would be x equals to plus or minus 8. That's the answer for part A. Right. For part B, they want you to draw the modulus of fx graph. Right, let's go with fx graph first. Fx has a graph in this way, where you intersect the x-axis at the origin and at the point x equals to 5. So the turning point here should occur when x equals to 2.5. So when x is 2.5, let's find the y value first. 2 into 2.5 square minus 10 times 2.5. So let me use the calculator for that. That is minus 12.5. So turning point would be 2.5 comma minus 12.5. That's going to be our turning point, and this part here would be reflected. That part should be reflected, and the rest of the graph will remain the same. When you draw the modulus function, the rest of the graph will remain the same. And here we go, we can draw this, and then we have to draw something like this. So this is y equals to modulus of fx, and this point here is 12.5, and this is 2.5, that is 5, this is 0. So that's the graph. Now the inequality we have to solve here is modulus of fx being greater than or equal to 5 by 2x, in other words 2.5x. So this graph in the left hand side is already there. We need to draw the graph of y equals to 2.5x. So this one goes to 0 comma 0. Also, when x is 2.5, y can be 6.25. So that is a reference which says almost like here. So let's draw that graph. That should go through the origin, also go to that point, indicating there can be 3 intersection points. Yep. So one is here, and the third one being here. Let's call this A, B, and obviously this point is O. So we need to solve this at intersection points. At point of intersection, at points of intersection, we could say the original part of the graph stands for 2x square minus 10x being equal to 2.5x. So you could say 4x square yeah, we can say 2x square minus 12.5x equals 0. So that is 4x square minus 25x equals 0. Take x out. 4x minus 25 being equal to 0. Alright, so this would give you x equals 0 or x equals to 6.25. So these are the x coordinates of O and point A. Right, so point B, this is O and A. At point B, we could say, sorry, it is point O and B. At point A, we could say the reflection of fx, which is minus of fx being equal to 2.5x. Minus of fx would be minus 2x square plus 10x being equal to 2.5x. So you say 2x square minus 10x plus 2.5x equal to 0. So 4x square minus 20x plus 5x being equal to 0. So 4x square minus 15x is 0. X into, and this is between 0 and 5. Right? This inequality range should be between 0 and 5. That's where we reflected it. So that's 4x minus 15 equals 0. So x equals 0 or x equals to 3.75. We don't take this because we've already taken that. So this is the third point, point A. So when do you think the given graph is above the green line here? So you can say until point A, the straight line is below the curve, and it is above the curve only between point A and B. So the solution, we can suggest x being less than or equal to 3.75 union, when x exceeds 6.25 also, the curve is above the graph, the modulus curve is above the graph. So this should be our final solution. We found the intersection points, and then we figure out, if I highlight this, until this point the curve is above the line, so that reflects these x values. That's x less than or equal to 3.75. that's the coordinate of point A. And then again, from here onwards, the curve is above the green line, that means from this point onwards, again that's 6.25. So that's where we have the x values that satisfies the equation.